Welcome to Brain Vision.
Interesting question. It says that a transport plane takes off from a level landing field with two gliders into one behind the other. So let's say this is the plane. This is the plane over here. Oh, it looks like a train, but it's actually a plane. So let's so let's make a box over here. Let's say this is a plane, and we have two gliders into one behind the other. So this is the glider one. Let's make it as a bit smaller one. This is a glider one, and this is the glider two, and they are all running together. And these gliders are each of mass 700 kg. So this guy and this guy is of 700 kg. Now, the total drag friction, as in the air friction plus of the runway, along with the air friction, along with the air resistance and the friction, assumed to be a constant and is equal to 2500 Newton, and that is on each. So it means that this is getting pulled by 2500 newtons, and this is also getting pulled by uh, 2500 newtons. All right. So if the maximum tension between the transport plane and the first glider is not to exceed 12,000 newtons, it means that this tension cannot exceed more than, or we can say that T max is 12,000. Then what is the and if a speed of 440 meter per second is required to take off, then what is the minimum length of the runway required? So if you're talking about the minimum length of the runway means how much minimum should the plane travel, and minimum is traveled when the acceleration is maximum, and the acceleration is maximum when the force is maximum. That's why we're going to take the maximum tension into account for this one. All right. So now we are gonna try to form the equations over here. So what is the minimum length they are asking for? So we have to set up the equations, which looks like. So for the first glider, let's call this tension to be T1, and for the other rope, let's call this tension to be T2. So for the first one, since it is accelerating, let's say with an acceleration of a, so the equations of motion are going to look like, equation of force is going to look like T1 minus T2 is equal to ma, so that's 700 a, and T2 minus, sorry, there is another force of 2500. So T1 minus T2 minus 2500 is equal to 700 A, and T2 minus 2500 is equal to 700 A once again. So I'm just writing the equations for, let's call this the second glider, and let's call this the first glider. So this is for the first one, and this is for the second one. So let's what can we do is, since we are already only given the value of T1, uh, so we'll try to eliminate T2 over here. So let's add both. If we add both, then T2 is going to be cancelled. So we are left with T1 minus 5000 is equal to 1400 A. So from here, we have the value of T1 as 12,000 minus 5000 is equal to 1400 A. So this is going to be now equal to, I'll just grab my calculator. So this is 12,000 minus 5000 over 1400. So this is coming as 5 meter per second square. But we are not really interested in the acceleration. We have to find the minimum length. It means that we're going to now use the equation of the motion. So the equation of the motion, I think we're going to use the third equation, which is v square is equal to v naught square plus 2as. The speed with which it has to take off is 40. So this is 40 square. Initially it is at rest, so 0 plus 2 times 5 times s. So the s is going to come out as 400, that is 16 for 40 square, which is 1600 over 10, which is coming as 160 meters. So this is the required answer for part A, as in what distance it must travel to come at rest. So to come at that particular speed. So this is how it looks like. uh, Now the next one talks about what is the value. The next part talks about what is the tension between the rope which is connecting the two gliders. In other words, they are asking the value of T2. So that would be pretty much easy, because from the equation number 2, we can get the value of T2. So I'm gonna write over here that B from second, the T2 is equal to 2500, adding 2500 both sides, 2500 plus 700A. We already have the value of A as 5, so that's 2500 plus 700 times 5. So that's got to be equal to 700 times 5 plus 2500. That's coming as 6000. So the tension in the other loop is 6000 newtons. Thank you.